area is the space in a two-dimensional realm, okay? Normally you think of area as length times width or base times height. These are basically referring to quadrilaterals, right? So squares, rectangles. A square, instead of saying length times width, you might just say side squared, which is the same thing. Or if I'm talking about a triangle, I might say base times height divided by 2, or 1/2 base times height. Okay, those are some basic formulas that you have heard of in the past. They're written over there on that red poster to the below and to the left from my clock. So if you're ever baffled as to what any of the formulas are, they're up there, area and perimeter. Now, for today, what we're going to learn about is areas when you have to find different things, like maybe you have to find a poster and its border, like in the picture there on the top of page 172. Or maybe you're doing a swimming pool or perhaps a pond, as in example 1, and you're figuring out how many bricks to buy in order to create a specific walkway. These are real world problems, gentlemen, that your wives are going to be having you do for them after you put their pools in for them. So pay attention. So let's start with the top one. This is the photograph that is 8 inches by 10. Okay, so I'm going to just do this one. I want to make sure we're pretty clear on this. 8 by 10. Pretty common measurement. Most of you, when you bring home pictures for mom from school, she oftentimes orders an 8 by 10. So a photograph is 8 by 10 and is surrounded by a border 2 inches wide. They call those mats. If you were in the art class, you might have learned a little bit about it, or those of you that are just artistically inclined. Okay, so mine's not very even. Kind of failed up at the top there. Okay. So the inward area is 8 by 10, right? But if I want to include perhaps the mat and say to you, what is the area overall? So that is mat plus the border. Well, if I were to find this length, I would say, well, the picture is 10, one side of the border is 2, the other side of the border is 2, so 14 is what we're looking at here. And over here, it's 8 plus the border, which is 2 and 2. Of course, you could have just said 4, right? Which equals 12. Now, this entire thing is 12 by 14, right? But the question asks, a photograph 8 inches wide and 10 inches long is surrounded by a 2-inch border. To find the area of the border, you subtract the larger one's area minus the smaller one's area. Okay? So I've already shown you that the larger one has an area of 12 by 14. Right? 12 by 14. Which equals 168 inches squared, right? That's the entire area. But if I subtract out the print, which was 8 by 10, otherwise known as 80 inches squared, I would end up with just the area of the border. The area of the border is 88 inches squared. And that answers the question that they were trying to describe to you. Now, real world applications, like I was saying, if you were building a brick walkway around a square shape or a triangular shape, when you go to Menards, they're going to sell you the bricks in square feet. And the easiest way to find out how many bricks you need is to know the area of the shape around the thing that you're bordering. The below problem is exactly that scenario. So I'm going to go ahead and do that one with you guys. Hector made a rectangular fish pond surrounded by a brick wall 2 meters wide. So here's his fish pond. And his brick wall that goes around it is 2 meters wide. Okay? 2 meters wide. He had enough bricks for the area of the walk, this portion here. He has enough bricks to cover 76 meters squared worth of bricking. So, what are the dimensions of the pond if they tell us the pond is twice as long as it is wide? Twice as long as it is wide. Okay? Alright, so we know the pond, I'm just going to write all this stuff out. These are really tricky. We know has an area of 2W times W, right? And we know that the entire thing, pond plus walkway, entire thing is 2W plus 2 and 2, because remember it's 2 meters wide, so it's 2W plus 4. Up, down, it's W plus 2 and 2, which is 4. Okay, so the entire thing, I'm going to write over here, is an area of 2W plus 4 times W plus 4, because we added in the 2 meters that they talked about there. Alright? But what they actually want to know is the dimensions of the pond. Okay? And the way to find this, the pond only, is if you know the overall dimensions. If you know the overall dimension, which is pond plus walk, which I have right here, and I subtract out the pond dimensions, which I have right here, it should equal the walkway only. Okay? It's just like saying, I want to weigh my dog, so I step on the scale myself, get off, I write that number down, and then I pick up my dog, and I get on the scale with my dog, and now I weigh a bunch more. If I subtract the total minus me, I get the dog. Okay? That's literally what we're doing here. So, let's see what they have for us. They tell us the area of the walk is 76, and the overall is this product, 2W plus 4 multiplied by W plus 4, from which we're going to subtract the area of the pond, which is 2W times W. Okay? I'm going to squeeze it in here. First, we have to solve what this is by foiling it. First, 2W times W is 2W squared. Outside is 8W. Inside is 4W, which adds together to give you 12W. That's outside and inside. Last, 4 by 4, which is 16. Okay? Negative 2w multiplied by w is negative 2w squared. All of that equals the 76 that they gave you to begin with. Okay? Combine like terms. Looks like your w squareds, a positive and a negative, cancel each other out. Okay? 2w plus 16 equals 76. 2w plus 16 equals 76. Stay with me. If you follow the steps, you'll be fine. Subtract 16. 2w equals 60. So that means if you divide by 2 is w 30. Does that make sense so far? All right. Find the dimensions of the pond. If w is 30, that is this measurement here. 2w then is 60. Okay? Which means the dimensions of the pond is 30 by 60. If I did my arithmetic right, which something is wrong.
Was it 12W, not 2W?
Awesome. 12w, not 2w, Mrs. Myers. 12, 5. Thank you. 5 and 10. Thank you, thank you, thank you. 5 and 10. Okay? Very good. Let's do the orals. Okay? All of these are very similar and it just takes the same process. So this is oral number 1. Okay, drawing really helps. A rectangle is, top of page 173, 5 longer than it is wide. So that means W is W, length is 5 longer. Does everybody see how I came up with that portion of the drawing? Okay. If its length and width are both increased by 3, so dot, 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 3 more, dot, 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 3 more. Okay, it's going to match. So I added 3 here, and I added 3 here. Its area goes up by 60. Find the dimensions of the original rectangle. Okay, so that means that this portion here, this little addition, is almost like the border of the walkway. Okay, that's the extra piece that is added by the 3 units that are added, which means the additional space is equal to the area of the large, which is W plus 8 times W plus 3, minus the area of the small, which is W plus 5 times W. Okay? So, additional area equals larger minus smaller. Okay? So this is like saying dog equals 2 people standing on the scale minus me. Okay, again, I'm not smaller, but you get the idea. All right. So let's start solving this. 60 equals, first we get W squared, outside and inside, 8 and 3, which is 11. Last is a positive 24. This one, negative W times, because this negative goes over both of these pieces. Okay, I could have written it this way, W and W plus 5. Let's make it that way so that it's easier to see. Okay, this negative applies to this W. So negative W times W is negative W squared. Negative W times positive 5 is negative 5W. Okay? Combining like terms, the squares cancel out, which is a good thing because you don't know how to solve that kind of problem yet. and the 11 and the 5 results in a 6. Okay? So 6W plus 24 is equal to 60. Okay? All my arithmetic good? Subtract 24. You get 36 equals 6W. Divide by 6, and you get 6. Now, what are they asking? Find the dimensions of the original rectangle. Well, the original rectangle was W and W plus 5, which means it is 6 by 11. 6 by 11. Okay? If they asked for the larger one, you would have said W is 6, so 6 plus 8, 15, 14 I mean. W is 6, 6 plus 3. This is the larger one. If they asked for it, you could find that. Okay? And if you actually took the product of this and subtracted the product of this, you would end up with that. That's another way to check yourself before you wreck yourself. All right. One more. This is oral 2. And yes, expect to use a lot of paper because you're going to draw, you're going to make mistakes, but you have to try. You can't just put your hands up and say, I don't get this. That's not acceptable. Try. A rectangle is 10 meters longer than it is wide. All right, so I'm going to draw out a rectangle. W plus 10. Does everybody understand that? It is 10 meters longer than it is wide. If its length and width are both decreased by 2, so that means I'm going to go in by 2. Okay, I'm making it smaller by 2. Its area is decreased by 48 meters squared. Find the original dimensions. Okay, so the change in area is equal to the larger area minus the smaller area. Okay, that'll give you the difference. Okay, we've already been given the change, which is 48. Okay, the larger one, W plus 10 times W, right? Minus the smaller one, which is W minus 2 and W plus 8. Do you guys see how I took the 10 and removed 2 like they told me to? So it's W plus 8. Okay, let's work with these two. Are W squared plus 10W. And then we will assign this negative here in a minute because it's subtracting the product of all of this. So W times W is W squared. Outside and inside is positive 8 and negative 2, which is positive 6W. And last, negative times 2, or negative 2 times 8 is negative 16. Okay? But we are removing this from that, which means the signs that we obtained by multiplying have to be flipped. We are removing W squared. We are removing 6W, and we are removing a negative. Removing a negative makes it positive. So everything you have here can now be worked out. The W's get combined. W and W are negative. Cancels out. A 10 and a negative 6. 4W. Done with those. And a positive 16. All of that equals 48 meters squared. Okay? Subtract 16 and you get 32 is 4W. Divide by 4, and you end up with 8. But let's see what they wanted. They want the original dimensions, which is the rectangle before it shrank. Okay, the original dimensions are W and W plus 10, which means it's 8 by 18. Okay. This phrase right here, the change, whatever they tell you was added or subtracted to the rectangles, think of that as the change. And then find the difference. Okay? Solve for the variable and then plug in the variable for what they want. Since they wanted the original rectangle, I used these. But if they wanted the new rectangle, I would simply use these. So this is the original. But if they did want the new, I could tell them. The new one would be W is 8, so 8 minus 2, which is 6. W is 8, 8 plus 8 is 16. Is that a shrinkage of 2? Yeah. So you can check yourself that way too.